Hello everyone, welcome to my 5th video installment of the Typing Math series. And today I figured after I talked about subscripts and superscripts of equations, we're going to practice it out by typing out non-math but STEM high school related subject equations. So we're going to be taking equations that are seen in biology, chemistry, physics, and economics from high school. I think most of these either come from the IB or AP curricula. So let's start with biology. And note, I'll be going over these very fast, so I won't have any time to go and spell out the pseudocode keystrokes you need to do. So let's take a look at what's particular one, the chi-square test of distribution. So all you need to do is like type in the chi here and square it. And then it is being put underneath a summation operator, which you can find under the big sum guy here. Go and select it. And then you'll get O minus E squared divided by E. And of course, it's always good to denote what your symbols means, but O means observed results, and E means the expected results. So one is the theoretical versus the other being the practical. Here's another one that comes from Mendelian genetics. It's the Hardy-Weinberg equation. So you basically get that P plus Q squared equals P squared plus 2PQ plus Q squared equals 1. Given that P plus Q has to be 1. And what does this mean in genetics? Well, it means that P is the frequency that the dominant allele in the population has. Q equals frequency the recessive allele is in the population. So in other words, P squared would be the same thing as if we let the dominant allele be denoted with a capital A and the recessive allele be denoted with a lowercase letter, then that means that your P squared is the same thing as A squared. Your Q squared is the same thing as A squared, and then your 2PQ essentially equals AA. That's a Hardy-Weinberg equation being used for genetics in high school biology. This is a chi-square test. Finally, one last biological equation will be, well, let's use the logistic growth model, which will use derivatives. So I can type this out as dn by dt equals r max. So you can see here I have a subscript. And there's a bit of a problem you have. You have to be very careful. Max by itself can mean like taking the maximum of something, but we really want to use it as a symbolic purpose. So best way to go and avoid this kind of mistake is to just, let's see, type A. Yeah. It's a bit hokey, but you have to go and like type in MA, then press the space bar, and then afterwards go and type in the X afterwards. Otherwise you'll get a maximum argument, which you only need to care about in analysis. Anyhow, I'm speaking too much. So then times N times K minus N, and that is all divided by K. And of course, what do these symbols mean? K equals the carrying capacity of a population. N equals the population size. And R max equals maximum per capita growth rate of your population. So that's all there is to it. I think that's enough equations from biology for now. Let's go and transfer to chemistry. And here are some pertinent examples we'll use. Let us go and do the ideal gas law. That is simple. That's just PV, pressure times volume, equals N times R times T. It's the ideal gas law. Here's another one, the rate of diffusion equation. Again, I'm not a chemist, so I really don't know what's going on here. Rate subscript 1, all this is just a typing exercise for the most part. Rate 1 over rate 2 equals square root of M1 divided by capital M2. Whoops. There we go. And this is just using the square root expression, which you saw it as typed as square roots, like this. But if you want, you could always express this in fractional exponents, which is the way I would actually rather go about it. So I can type it out as this raised to a half power. And it means the exact same thing. I can have the pH equation of the solution. Here is one of them. You get that pH equals negative log base 10 of H subscript free, some hydrogen molecule, I would guess. Again, I'm not an expert at chemistry, so who cares if I'm wrong or not? Yeah, like that. That's a particular pH equation of a solution. And finally, let's take a look at Gibbs free energy, which basically gives us delta G equals delta H minus T delta S, where delta G, change in Gibbs energy, delta H is a change in enthalpy, T is the absolute temperature, Kelvin, and delta S is the entropy of your solution. And let's just do an example of typing in the chemical formula of a substance. So finally, let's take a look at typing in the chemical formula of a substance. We will have here glucose, which is described by the following chemical formula: C6, C subscript 6, H subscript 12, O subscript 6. And we are essentially done at this point. So let us go and transfer to high school physics equations now. Here, let's take a look at the neat one. I'm going to be writing out Faraday's law, which will require use of an epsilon. And I mentioned that the best one that I think you should use is the variable epsilon. So we're going to go with that. So that equals negative n times d phi, sorry, not d theta, d phi by dt. Yeah. Faraday's law just says the rate of change, it says the total electrical energy is proportional to the derivative or rate of change of flux with respect to time. That's one candidate there. And then there are a couple of like other equations that are dealt with that, like flux. Let's go and take a look at electromagnetic flux. Right away, what is electromagnetic flux defined as? It's defined as phi equals, make it capital Phi, equals BA cosine theta, which is essentially the dot product of the magnetic field strength and the surface area you're dealing with. So technically these should be having absolute values in front of them, corresponding to the geometric definition of the dot product. And here's some more. Well, let's look at the Stefan-Boltzmann law equation, which says that luminosity equals some freaking constant times the surface area multiplied by the absolute temperature raised to the fourth power. Here's another guy. I'm going to explain how it works. We'll go into relativity now. And I'll get relativity. So E squared equals P squared times C squared plus M naught squared times C to the fourth. So there's one, that's the total energy. For some mass energy equivalence thing. Of course, we have the true form of Einstein's special relativity formula, which is E equals some constant gamma times the rest mass times the speed of light squared. So M naught equals rest mass, C equals the speed of light. It's always a good key in general to go and define what your symbols mean. And finally, we'll go to fluid mechanics and take a look at Stokes' law, which takes a look at the viscous drag force of liquids that are, I assume it's laminar flow, and it's only at certain speeds. So you get that the drag force of a liquid equals to 6 pi times eta here, RV. I would believe that R equals the radius of your cross section. V equals fluid speed, and then pi and eta are just like other random constants. Finally, let us go to economics. I'll give 2 examples and then we'll be done. So apparently, I never took economics before, but there's something called like a budget line for good X and good Y, 2 different arbitrary goods. If we denote that QX equals quantity of good X, QY equals quantity of good Y, and we have that P of X and P of Y equals their prices correspondingly. Oh yes, and income. Let's let I equals income. If this is the case, then this equation must hold. I equals Q subscript X times P subscript X. So the quantity of good X times the price of good X plus the quantity of good Y times the price of good Y. So that's it. And then the quantity and price are inversely proportional related to one another with regards to the income, because you can represent each as this, I times P over Y, and this. There's a thing called consumer price index, and we'll be using summation notation, which I will go over in more detail how you can build that out later on. But you just have CPI, let CPI equal consumer price index. CPI in the first year equals, and now let's go to the large operator and put in the giant summation here from lower index I equals 1 to I equals n. Is simply defined by I1, W of I1, P subscript of I1. All of this being divided by W I0, and then P of I0. And that's a nasty thing which happens, fortunately, when you type things out. There'll be a break. You should cut it out and then paste it here. Just a little problem that you should be aware of when you're using the equation editor. And then all of this times 100. In this case, W equals the weight associated to commodity in household expenditure. You then have P equals, and this simply becomes the price of the commodity. Then you will have N equals total number of commodities in the basket of goods and services index. Whatever those mean. I have no idea what those mean at all. I'm not an economist. And finally, our very last guy, again, I have no idea what it means, but there's this thing called the slope of indifference curve. Good X and good Y. So we have the slope. We use the letters IC to indicate the indifference curve, first two letters of indifference curve. And this equals capital MU subscript X. And it's safest to go and put this in brackets, divided by capital MU subscript Y. And then each of these are defined as MU subscript X equals marginal utility, good X. MU subscript Y equals marginal utility of good Y. And that's all I have to show you as practice equations. So I hope that this video was useful. Please give me any feedback if there are anything that can be done to like improve this particular kind of practice video. I might post more practice videos in future. Until then, I hope that you have a nice day. Take care.